Riggs, how's it going?
Good. It's almost like it's a special day or something today.
It is a special day. What is that day today?
Is
Hmm.
this is
Cinco
this
de
your
Mayo.
Cinco de Mayo?
I don't know about that. I think
Is
it's
No?
that it?
another special holiday.
Riggs, welcome to the show. Can you go ahead and introduce yourself to our audience?
Yeah, sure. So my name is Riggs Goodman. I'm the technical lead for the networking partner segment at AWS, and I work with a lot of the networking partners on service integration, including verified access.
Now, what is verified access?
Yeah, so verified access is actually something that we launched last Friday. We announced it as a preview at reInvent last year. But to your point on VPN, what verified access is looking to do is provide secure access to applications deployed on AWS without the use of VPN. So when users want to connect to applications on AWS, they can connect into verified access. And verified access is able to integrate with different trust providers, both identity and device trust providers, to provide that secure communication to your application on AWS, and then connect to the applications deployed on AWS.
Now, when you're talking about applications, are these like Java web apps that you're connecting to that you're able to allow, say, your users to connect to from any device, but based on the type of device they're on, you get to apply certain conditions to that?
Yes. So today, with the way that it usually works with VPNs, is when you connect to a VPN, it's kind of an implicit trust that if you're on the VPN, then you're going to have access to the application. What verified access is really looking at is kind of, if anybody's ever heard of the zero trust, really using zero trust type policies and using different claims from both device trust providers and endpoint device management trust providers in order to grant applications. So, for example, if you're looking to go to your HR app that exists on AWS, when you hit verified access, it's going to see if you're logged in or not. If you're not logged in, it's going to redirect you to a login page where it's going to make sure that you log in, whether you're using MFA or something like that. And then that identity provider, whether it's Identity Center or a third-party trust provider, is able to give claims back to verified access. These claims might be your email address, groups, and other things that might be important that your company wants to check to make sure that you're a part of. And then the other thing that it also does is it allows for device trust scores from your actual device to be sent to verified access so you can write policy against it. The overall goal that we have with verified access is actually to have a centralized place to actually write per app policy. So you can use those claims that you get from both the identity provider and device trust provider to permit or deny access to your applications compared to what you have today with VPN, which is more of an implicit trust.
Now, for those that want to see like the technical like setup of this, as far as like an architecture diagram, do we have anything like that that we can kind of share on screen for our audience today, so they can get a better understanding of what that looks like architecturally?
Yeah, can you see my slide on the screen right now?
You know what? I can now.
You
There it
can
is.
now.
I
Yep.
So
can.
I had to slide up, but no one actually could see that. All right, so
I was in
this
stealth
is kind
mode.
of so this is kind of what it looks like. So when you have a user who is looking to connect to an application, it's going to go to some DNS request, so your hr.com DNS entry, and that's going to point you to verified access. What verified access is really a reverse proxy where we're using that information from both the identity providers and the device trust providers in order for you to write policy against your applications. These are web applications today. So these are HTTP, HTTPS applications that are deployed on AWS. And once the user is logged in and it goes through the policy, that policy is going to make a decision on whether or not you are allowed access to that application or denied access to that application. If you are allowed access, verified access is actually creating the communication from verified access, which is a native AWS service, to that VPC. That VPC target could either be an application load balancer, a network load balancer, or an ENI, depending on exactly what type of application that you have. But we're building that communication between verified access to the application itself in order to allow users to access those corporate applications in a secure manner.
Riggs, I got a question. I know what you've just said sort of is going to answer my question, but can we take a step back and really explain the concept of zero trust? And I realize you've just kind of explained how verified access provides you that zero trustability. But can you just summarize, start at the beginning with zero trust, and then again, just really quickly go over how verified access gives you some of those qualities?
Yeah, sure. So zero trust is a concept of when you have users connecting to different applications, so you using an app application, that there's not an implicit trust. It's not that if you're on the network, so if you're at a corporate office, then you can access any corporate application that you have. Every time that you make a request using zero trust principles, the application or verified access in this instance wants to validate you with every request. So when you try hitting verified access, you try hitting one app, it's going to make sure that you have logged in, you're part of a certain group, you are a corporate employee and other things like that that you can get from the identity provider. But it also wants to check from a device trust provider, what is your computer risk score? Do you have your firewall turned on? Do you have encryption on your device? And you can use that information from both the identity side and the device side to make decisions on whether or not to grant access to the application.
Yeah, and then
Compared to go ahead.
on top of that, it's not just the first time you log in; it's with
Correct.
every single request.
Yeah, and that's an important thing with verified access that we do it on every single request. Every request that you have, where you had to make that first HTTP handshake that you have, we are going to run it through the policy. So for if some reason your device trust score changes and it goes from, let's just say 100% down to 80%, and your policy tells you that you can only access this application if it's above 85, then it's going to deny you application even though you're already logged in, you were granted access to that application before.
So we actually have a couple questions that are coming into the chat, and I believe someone asked, "Is it similar to IAM roles?" And I believe you are you utilizing IAM roles as part of this verified access, or are these two still separate?
No, so these two are separate. There's also, and there might be some confusion because we came out with verified access, but we also came out with something called verified permissions that does use some with IAM roles. But verified access is not doing anything with IAM roles. It's more of providing that communication from verified access after it actually runs it through the policy to get access to the AOB, the NOB, or the ENI once it's actually permitted through the policy. If it's not permitted through the policy, then you're just going to get denied at verified access. And for example, get a 403 error when you're trying to access something as a user for that application.
Okay. Now, I love talking about all this stuff, but what really, really makes me happy and excited is being able to see demos of this stuff.
Well, good
If I
news, I do have
recall,
a demo.
you do have a demo.
Yes.
I love to hear
Yeah.
it.
Let's see. Whoa,
Oh yeah,
that was strange.
that was like we were
Trippy
in hyperspace.
I know, and it just kept going, going, going.
Yeah,
Almost like
then.
Star Wars.
All right, so it looks like we're in the AWS Management Console, and we're in
Yes.
IAM Identity Center.
Yep. So the demo that I'm going to show today is I created two different applications. One is an HR application and one is a sales application. In order for a user to be able to grant access to the application, for the HR application, you have to be an HR user. Right now, I have an HR user as HR user and an admin user. If you want to get access to a sales application, you have to be a sales user or an admin user. With verified access, we integrate into Identity Center, but we also integrate into third-party identity providers. Because one of the things that we want to do with verified access is make sure that we're going where the customers are. So if you currently have an existing identity provider that integrates into Identity Center as a third party or supports OIDC integration, then that can be integrated into verified access so you can get claims from that identity provider in order to access the application on AWS. So for this demo, I'm just using Identity Center, two groups. I have three users. HR user is only part of HR group, sales user only part of sales, and then the admin user is part of both. All right.
Sounds good.
Yeah, so within verified access in the console, you can actually find this in the VPC section of the console, down towards the bottom in this whole section with verified access. But the way that it works with verified access is you need to set up what we call trust providers. So this can be an identity trust provider with Identity Center is what I have here, or it could be a device trust provider. Today we support two, which are Jamf and CrowdStrike, that partner with us in order to do that integration. When you set up a device trust, or excuse me, a trust provider with verified access, you give it a certain policy reference name. I'm just using IDC policy, and the importance of this policy is when you want to reference stuff that you receive from that trust provider, you have to reference this policy name in the policy that you create in order to either permit or deny access to that application. So once you actually create the trust provider, then we have a concept of what's called a verified access instance. Basically what it is, it's a wrapper where you can include different types of trust providers, both identity trust providers and device trust providers. So I just have a simple workshop instance, and in here, I have two different, or one trust provider. And then as part of the instance, you can create something that's called a group. What a group is if you have multiple different HR applications that you want to have the same policy, you can create a group and write a single policy that can apply to all those different applications. So I have an HR group that's going to have a single policy for HR, a sales group that's going to have a single policy for the sales group, in order to write a single policy for all those different applications. Inside the actual group itself, you can write a certain policy. This policy is written using a Cedar policy language. This is something that we also announced at reInvent that works with both verified access and verified permissions. But it is a policy language that you can use in order to match on different things that you come in with the different trust providers, both on the device side and on the identity side. So for example, in this, I'm basically saying, and this gets back to referencing the trust provider, the IDC policy, if the group has the group ID, which is something that came from this group right here. So this HR group, you have a group ID, then you're able to match on that. And as long as that and the email address ends in example.com, which my users over here, their email address right here is salesuser as example.com, then it's going to pass you for that application. For the sales group, same thing, except now it's a different group ID, which is the sales group, in order to pass you to that application.
Riggs, you had mentioned device capabilities, but can you give us some other examples of other types of contexts that you would have in this policy? I mean, we have group, membership, and email address. What other things off the top of your head could you view by?
Yeah, so I'll actually show you something. There's something called the Cedar Playground, where you can actually mess around with different policies, where whether it's a device policy, an identity policy, where you can say, this is what the policy I have, and then this is the information that we're receiving from the user with the request. And so in here, you just have like a simple group. This is for an OIDC instance, and the email is verified true. But as an example, let's just say if you're using CrowdStrike has an example of an assessment score. They have overall assessment, they have an OS assessment, a sensor config assessment. And so you can match on what the assessment score is. This is a number compared to a string. And it also gives you additional capabilities. Like for example, Jamf, they do it by risk score, which can be low, medium, high. And so you can mess with a policy in this Cedar Playground in order to understand exactly, okay, this is what I'm going to receive, and whether or not the policy works. So this is just some additional examples of what can be in there.
Because I was curious, you want this to be pretty strict, obviously. So what if there were things that you could look at, but if you didn't realize it? So it sounds like from the partners and the models you're going off of, you will at least be able to see all of the options you have to measure, to write your policies from.
Right. And with, for example, other third-party providers that support OIDC, it's somewhat up to you on what you send to verified access. That if you want to have something that's company specific, you can include that in the user claims that you send to verified access that you can match on. So if today the only thing that you want to match on is group and email address, but then in the future that you want to be more strict and you want to see what country they're in, or you want to add additional things with the OIDC providers, you can add that as something that is sent along to verified access with all these other different claims. And all you had to do is just update the policy to match on it.
Perfect. Cool.
All right.
And
So the
then, so
last
for
thing
those that are, sorry to interrupt there, Riggs. So for those that are just joining us, we are AWS On Air, and today is a very special security episode. And right now we're learning about verified access on how we can provide, device context and risk and identity to be able to access a web-based application on AWS. And Riggs is going through a demo on how to go about doing that. So if you've joined us today, stay for the security and stay for the jokes that ensue throughout the next couple of hours as well. But Riggs, sorry, go ahead.
Yep. So we've created a device trust provider, which is Identity Center. We've created an instance. Inside the instance, we've created 2 groups. And so the last thing that we need to do is create an endpoint. The endpoint is the actual application that you're looking to connect to. So for example, this HR application, in here, you're going to include things, for example, what is the application load balancer that you're going to?
Right.
What is the endpoint or the group ID, the instance ID that you want it to be a part of? And then verified access is going to build that communication from verified access to that application in one of your VPCs in order to, once a user has been granted access through the policy, that you'll be able to access that application.
So that
So for
sounds
this one,
that sounds like the load balancer can be in a private subnet.
yes, and we want those load balancers to actually be private load balancers because we don't want them exposed to the internet. We want customers to be able to use verified access to be granted the application, and not someone being able to go directly from the internet to that load balancer in order to access it.
Well, there's a lot of features, but that is a big one. That is a very
Yes.
key security feature that I can see that this has a big advantage for. Continue, Riggs. Thanks.
Yep. So for the HR endpoint, I just have a simple domain, which is AVA0. And then for the sales endpoint, I have a simple domain, which is AVA1. So if I just go into an incognito browser and I try opening this up, what you're going to see is because I'm not logged in right now, it's going to redirect me to a sign-in page with Identity Center. So if I just put the HR user and then put in my password, let's try this again.
I can see your password's a bunch of dots. So is mine.
Forgot something at the end. That is going to check and then send those claims to verified access. And with the policy, with the HR policy, if I can actually get back to that screen, that policy is basically saying that if I'm part of the HR group and my email address ends at example.com, then I'm going to be granted access. If I try to do the exact same thing with AVA1, since I'm already logged in, this is the sales application. I'm going to try going to this. We'll get redirected, and I have a 403 unauthorized because with a sales application, I'm not part of the sales group.
Awesome. Now, Riggs, something that we're getting asked frequently within our audiences, and maybe we'll use this to kind of wrap up too. Are there any use cases where this might be used as opposed to a VPN? Or how can you qualify using verified access versus a VPN when you want to start modernizing applications and building applications?
Yeah, so it really comes down to company policy that many times with VPN, user connecting from a certain corporate headquarters going on VPN, or even if you're a mobile user, you might have to connect to VPN in order to access certain applications. A lot of companies are looking at moving from VPN that they have today to using zero trust principles, which they want more than just, hey, you can connect to VPN and you can log in. I want to make sure that if they're using some device, bring your own device, that they have certain security posture information that is sent along. So it's not that this device is compromised. And then they're going to access certain applications, and a third party is going to be a malicious third party is going to have access to all that information. So that's why with both CrowdStrike and Jamf, that they're running assessment scores on your device to make sure that you're at a certain policy level, and they're going to send that information from the device to verified access to make sure that you're meeting the requirements that the company has set with verified access and using zero trust principles. So a lot of it does come down to what the company's policy is. Some people are still using VPN, but we see a lot of customers moving to zero trust principles, and verified access is a native service that AWS came out with in order to do that.
Yeah, Riggs, and I can see everything you've said the word policy a zillion times, and I can see with VPNs, you might have your Active Directory policies, your user policies, and then your VPN policies, and then network policies, and then separate application policies. Sounds like verified access can centralize all that into one policy to control all of everything I just said.
Yeah, and that's one of the nice things about verified access, that you can have that centralized policy, both for device and for identity. And it gives you options that you can have a group level policy. One thing I didn't mention is you can also have an endpoint level policy outside just the group that can run actually through two policies if you need it to. But with verified access, using that Cedar policy language and using that trust data that you receive both from the identity side and from the device posture side, it allows you to have those centralized policies to allow secure communication to those applications on AWS.
Awesome, Riggs. And thank you so much for your time today. And I know you have some folks that are hiding out in our chat today. And there's a workshop that if folks want to learn about doing verified access hands-on, they can go about going through that workshop. And I believe you mentioned that there's modules for how to use Identity Center and how to use Okta. So we'll go ahead and drop a link to that workshop in the chat for y'all to follow along with if you want to experiment within your own environment. So Riggs, thank you again. Sorry to say that the time has come where we say adieu. We say goodbye. Until next time,
everybody.
friend.
Until next time.
Until next
thanks,
time.
Riggs.
Take care.